Assalamualaikum. My name is Fatimah binti Ludin. I would like to present my final year project, and the title is Optimization of Heatsink Design for Effective Thermal Dissipation in High Power LED Street Lighting. Overall, I will present the introduction, objective, literature review, methodology, result and discussion, and also conclusion. As we know, LED lamp is high energy efficiency, high luminance and low lifespan. Therefore, LEDs are vastly used to light homes, hospitals and items for highway lighting such as traffic signal, road sign and street lighting. Heatsink is a device that effectively absorbs or dissipates thermal energy from the surroundings using a standard surface of film. The heatsink increases the area of interaction between the LED and the surrounding air and then increase the possibility of heat dissipation. That's why most heatsinks have a gap between film. The first right picture is the example of LED street lighting. And the second and the third picture is the difference between the different heatsink street lighting. The problem statement is the heat radiation generated by the high power LED shorten the lifespan of the LED street lighting. Then, the heat radiation reduce the luminous efficiency of high power LED street lighting. And the performance of different type of heatsink can affect the different thermal dissipation in high power LED street lighting. For the objective, there are three objectives. First one, to analyze the effect of heatsink parameter, namely fin type, fin spacing, fin height, and the thickness of base on heat dissipation. Second, to optimize the heatsink design that can effectively produce the best heat dissipation in high power LED street lighting. And third, to validate the effectiveness of the proposed heatsink design for reducing heat dissipation in high power LED street lighting. For the scope, this project covers to design and modify a model of heatsink for effective thermal dissipation. And the design of heatsink is limited for high power LED street lighting only. And the design and modeling of heatsink using a powerful tool which is ANSYS software. For the literature review, Lee et al. 2012 state that the depth and spacing of fin are significant factors affecting the fluid flow and heat transfer in the heatsink. Hisham et al. State that increase of fin length as the heat transfer, the fin efficiency decrease because of the decrease of fin temperature with length. For the methodology, there are 4 processes that have been carried out through this project. First, design of experiment using Taguchi L60 orthogonal array 4 power of 3 was used as the experimental design for the screening process. Then, design the heatsink model using ANSYS software. Next, steady state thermal was used to simulate the thermal. Finally, all the different types of heatsink design have been analyzed through the effect of reducing heat radiation in high power LED street lighting. Next, we move to the design of experiment. Table 1 shows the parameter and level of experiment that have 4 levels and 4 parameters, which are fin type, spacing between the fin, height of the fin, and the thickness of heatsink base. His and Lee 2050 state that the significant control factor that affected multiple quality characteristics of the fin heatsink were fin type, heatsink base, thickness, and fin spacing. Yati et al. 2070 say that the heat dissipation is the height is the highest for the fin spacing of 20.5 mm. However, the maximum heat transfer for the 8 fin sample can be seen at a fin spacing of 10.85 mm. The table 2 shows the data of experiment design using L60 orthogonal array. For the simulation result, the fin type is for the fin type of the actual heat sink is rectangular with the thickness of fin is 2 mm. The actual heat sink have 9 fins and have different height between each other. The spacing between the fin is 24 mm. The base of actual heat sink are rectangular with the size 230 mm times 260 mm and the thickness of base is 3 mm. The maximum temperature of heat dissipation of actual heat sink is 48.327 degrees Celsius. The first design of heat sink was 28.432 degrees Celsius of maximum temperature. Second, heat sink have achieved 38.244 degrees Celsius maximum maximum temperature. Third heat sink have 34.551 degrees Celsius of maximum temperature. However, the maximum temperature of fourth heat sink is 90.819. Fifth heat sink have 45.56 degrees Celsius of maximum temperature. The maximum temperature of sixth heat sink is 40.463 degrees Celsius. The maximum temperature of seventh heat sink is 36.247. The maximum temperature of 8 heat sink is 41.276 degrees Celsius. The maximum temperature of 9, 10, 11 and 12 heat sink are 46.942 degrees Celsius, 41.724 degrees Celsius, 37.375 degrees Celsius and 43.011 degrees Celsius respectively. The maximum temperature of 13, 14, 15 and 16 heat sink are 48.389 degrees Celsius, 42.634 degrees Celsius, 38.475 degrees Celsius and 44.632 degrees Celsius respectively. Table 3 shows the experiment design using L60 orthogonal array. Table 4 shows the response of signal to noise ratio with the highest rank is height followed by thickness of base, heat sink and spacing between the fins. Next, figure 2 shows the SN ratio plot graph for largest the better of the temperature. Therefore, the optimized parameter for this project are 21 mm for spacing, 40 mm for the height, and 5 mm for the thickness of base heat sink. For validation test, the equation is 7.1 minus 0.405 spacing plus 0.440 height plus 5.94 thickness of heat sink base. Therefore, the predicted value of temperature is 55.895 degrees Celsius and the actual value of temperature is 48.327. By using the relative error formula, we can get the value of validation test. So the value of validation test is 13.54%. As a conclusion, all the heat sink parameters, namely fin type, fin spacing, fin height, and the thickness of base effect on the heat dissipation performance. Next, the height of fin heat sink gives the biggest effect on heat dissipation performance, followed by thickness of heat sink, base, and spacing. However, the optimized parameter for spacing, height, and thickness of heat sink base are 21 mm, 40 mm, and 5 mm respectively. Finally, through validation process, the relative error between predicted and actual calculated was less than 15%, hence validate the proposed optimized parameter. That's all for me. Thank you.